Hello, everyone. We are Group Black Eyes. Our topic is the impact of investor sentiment on the volatility of China's stock market. My name is Yan Yinshan. In Chinese stock market, individual investors dominate the majority. Investor sentiment is an important factor affecting the stock market's volatility. To research this topic, we use Garch model to measure the daily volatility of certain indexes in China's stock market, construct two sentiment factors, and figure out the relationship between them.
My name is Chen Nang, and I would like to talk about how do our groups get volatility to different China stock markets. We do it through our Garch model. And the first step is to find is the return series stationary. In the PPT we do it as an example of CSI 300. So first step we do an ADF test and found that the return series is stationary since the p-value is quite small. And after that, we do a box linear test to the return series and found that there are some zero correlations in it. And then we do a box linear test to the square of the return test, found that the p-value is quite small, which shows that there are some arch effects in it. And we can also see it from the ACF graph on the right-hand side to get the conclusion. And after that, we use the ARIMA to get the order of the model. As for the CSI 300, we get the ARMA 3 and ARMA 33 and Garch 11 as our model, and we use Garch fit command to get the coefficients. And we can also see from the right-hand side of the PPT that all coefficients are significant, and the fitted model is shown as the downside. Both alpha 1 and beta 1 are highly significant, and beta 1 estimate equals to 0.943, which implies rather persistent volatility clustering.
Hello everyone, my name is Zhang Xiao. In the next part, we use two kinds of ways to construct our sentiment factors. The first way is to replicate the Chinese four-factor model. This model has been published in Journal of Financial Economics. This paper compares the differences between the Fama-Friend three-factor model and the Chinese four-factor model. We think we should clarify three important things. First, to construct the SMB factor, we must eliminate the bottom 30% market value stocks. Second, we use EP rather than BM to construct our VMG factors. Last, the sentiment factor is based on the turnover data because it can reflect two phenomena. First, individual retail investors are the most likely sentiment traders, and the individual investors are the major participants in China's stock market. Second, shorting a stock is extremely costly in China. Here are some more details about the construction of sentiment factor. The factor SMB and PMO are constructed simultaneously, so we should eliminate the bottom 30% market value stocks. Each day, we separate the remaining 70% of stock into two side groups and three turnover groups. So you can see there are 6 groups. Our size and sentiment factors are constructed through these two formulas. So we have built our four-factor model. Because we don't focus on the value factor, VMG, here we don't show the statistic of value factor. Our data begin from the 2007 to September 2020. From this chart, we can find that the average of each of the three factors is close to 0, and the correlation among the three indicators is very low. So the first sentiment factor, PMO, has been constructed. Thank you.
Hello everyone, my name is Zhang Zisheng and I will show you how to construct the fears factor. This page shows the construction of the investor sentiment factor. The factor was called fears, and the financial and economic attitudes was revealed by the search volume of some specific keywords. We used the search volume of 10 keywords based on the Baidu search index. The 10 keywords are Chinese in our project, but we just translate them in English here. We constructed the fears index by filtering the significant keywords. We normalized the data first and used the basic linear regression to detect the significance of the different keywords. And then we pick up the significant keywords to construct our factor. Here shows the formula of our factor. We just use the average of the normalized search volume of different keywords to construct our factor. And this table shows the data description of the normalized search volume of these keywords. In our project, there are 3,427 observations. This table shows the p-values of all betas between different keywords and stock indexes. It can be seen from the table that inflation and deflation are not significant. So we remove them and choose the search volume of the other 8 keywords and use our fears formula to calculate the fears factor.
Hello everyone, my name is Wang Zihao. Let me introduce the correlation analysis between the sentimental factors and the volatility for you. After we construct the PMO and fears factor, we use the most basic linear regression to detect the impact of the two factors on the volatility of the Chinese stock market. The first page is the result of linear regression between PMO and volatility. We selected the different stock sectors in China and used this formula to test the correlation of a PMO factor to different stock index and volatility. As the results show, we can see firstly, from the p-value, we know that PMO has a significant impact on volatility, and the value in different markets is basically the same. Secondly, in every one market, the value of beta is negative, which means investor pessimism is negatively correlated with stock volatility. In addition, we found that for different markets, the alpha value is significant, indicating that the investor sentiment may not be the only factor affecting the volatility. Next, we use the same method to test the impact of the fears factor on stock volatility. Firstly, the results show that the p-value proves that the fears factor is significant for the stock index in different markets. What's more, we notice that all beta values are positive, which means more investor attention may lead to a large volatility. Also, the beta shows that the fears factor has a great impact on large cap stocks in Shanghai Stock Exchange and has a smaller one impact on Shenzhen, as well as small cap stocks. We guess it may be because Shanghai stock has a large weight in the index, and the investor may pay more attention to the stock of this large company. At last, the alpha value of fears in different markets are all significant too, so the investor sentiment may not be the only reason for the volatility, and we will seek other contributing factors in the future.
The next part is the Granger causality test. To do this, we must ensure the stationarity of the series through the ADF unit rule test. PMO, fears, and volatilities of different indexes are all stationary. Another important thing is to determine the lag order. This test is sensitive to the length of the lag period. Because we use daily data, we start to try the minimum lag period. And we also use VAR select function to determine the order by AIC. Take all the results into account. We take order equal to 1. See the results below. P-values are small enough to say that the result is significant, which means PMO and fears are respectively the Granger cause of the volatility. It can be explained in common sense that investor sentiment has an impact on investor behavior, thereby affecting the volatility of stocks. At last, conclusion and reflection. In this project, we get satisfactory models ARMA-PQ and GARCH11 for the volatility in different indexes. And then we know that PMO and fears have significant positive correlation with volatility. But the positive effect of fears on small cap stocks is lower than that on large cap stocks. But in correlation analysis, there is a significant alpha in the linear regression, which means investor sentiment may not be the only reason for the volatility. And we did not consider the heteroscedasticity of the model. That's all. Thanks for your listening.